Dr. Lan and welcome to Lan's Lab. Here is where I will show you how to do some fun, cool and cheap experiments that you can do at home, because science happens everywhere. It doesn't just happen in a fancy lab with fancy people in fancy coats. You can do it wherever you are because science happens everywhere. Everything is a chemical. The most common compound in the whole wide world is water. You encounter it every day in all of its different forms. And when I say compound, what I mean is that it is two chemical elements that have been chemically bonded together. So that means that they've been stuck together in a very kind of specific way, and it is very, very hard to separate them. So they can't be separated from each other by physical means. You have to use something chemical. So water is a compound made up of hydrogen and oxygen. And if you were to encounter hydrogen or oxygen on a day-to-day basis, which you actually do, those are both gases. So those two gases together actually make our liquid water that we drink and use for life every day. As I said, it is very, very difficult to separate water and other compounds into what they're made of. So what we're going to do today to separate water into hydrogen and oxygen is this thing called electrolysis. And electrolysis, if you're to split up the word, not the world, is electro and lysis. Lysis means to separate. Electro obviously gives you a hint as to what we're going to do today. It involves electricity. If you're to do this in a school, often you use things like a Hofmann's voltameter, which is this big fancy piece of glassware, and that is not required. Obviously, if you have it, that's beautiful for you, love that for you, but we don't have that. So we're going to do with a normal glass, some water, salt is required, a few wires, a battery, and some pencils. Oh, also bonus cardboard might be necessary. Right, so why pencils? So pencils, we often call them the lead. The pencils is actually not lead. It used to be lead, but then we realized that lead was poisoning everybody. So we don't do that anymore. And inside of them is graphite. Graphite is a crystalline version of carbon, and it is a very good conductor, and so we can use it as an electrode. So as I was saying to my friends earlier, this is a good thing that we've swapped it to graphite, because as a 4-year-old I fell on a pencil and got the nib stuck in my chin, and I did not die of lead poisoning. I just have a graphite tattoo. So what we've done is we've shaved both ends, so we've got two pointy ends, two dangerous pencils, and that we're going to do that. So that way there's graphite at the top and graphite at the bottom. So the first step is we're going to need some water to actually separate. I'm going to put the salt in first. Now there are, I'm sure, very specific measurements that you can use, but a bit of salt, a hefty amount of salt. Okay, here's our now salty water, but I might just get something to help mix it up. So it looks all frothy now, but it'll calm itself down in a minute. It is now nice and clear, because you want the salt dissolved in there. You want it to have settled down so you don't see many bubbles, because what you want to focus on is the bubbles that you're making. So make sure that you have two pencils sharpened either side, a battery, some cardboard that we're going to pop over the top to hold your pencils in place, because what you want is you want part of the pencils submerged and some of the pencils out of the water. So we're going to try and get that sorted now. One at a time, Leanne, one at a time. Ah! No, I didn't stop myself, it's fine. So now we need to connect this up to a battery. So you can use normal I've got crocodile clips. If that works for you, then go for it. I also have this handy one that clips in very, very nicely to a battery. So I'm using a 9-volt battery. That seems to be a nice kind of voltage for this experiment. I'm going to connect it up to the power afterwards. This might be easier. Okay, so what we need to make sure is that there is an actual connection between the graphite, not the wood, and the wires. So I'm going to do that now. I'm sorry for the fiddly bits. Gorge. Okay, so now that they're set up, you can add some electrical tape if you want to make sure that they stay where they're supposed to stay. Crocodile clips can be better sometimes for clamping, but not always great. I'm sorry if you don't like the noise, that teeth situation. Whew. I didn't break my teeth. It's fine. Okay, please stay. Don't you dare move. Don't you dare move. Doo-doo-doo, this is so fiddly. Now, and so straight away, you can actually see some bubbles getting produced. Now, so the chemical formula for water, as you've probably heard at some stage in your life, is H2O. And what that 2 in there means is that there's twice as many hydrogens as every oxygen in there. So for each oxygen, each O, there are 2 hydrogens stuck to it. If you have a look at the bubbles that are coming off, what you can see is that at one of the pencils, there is twice as many bubbles coming off, but there's more bubbles coming off. And that will tell you that that pencil is where hydrogen gas is being produced, and the other pencil is where the oxygen is produced. So the one with more bubbles, that's hydrogen. The one with less bubbles, that's oxygen. And so what's happening at those pencil nibs is water is being split up into hydrogen and oxygen. We know that hydrogen is produced at the negative electrode, and that is the cathode, is what we call it. And oxygen is produced at the positive electrode, and that is the anode. So yeah, that's pretty much it, and I hope you enjoyed it and give it a shot at home. Am I Bosco now?